In this module, we are going to talk about forces. Okay, we have learned till now that F equal to ma is the governing equation for how a body moves, and in that I told you that this F is the net external force. Okay, there's something called force, which is what causes acceleration, is what we learned till now. But this net external force means that there could be n number of forces, the nature of which this law doesn't talk about. Okay, and the cumulative effect, if I can take out, the vector sum if I can take out, then I know that acceleration will be along that, and the magnitude of the acceleration will be given as force divided by the mass of it, mass of the body. Okay, so now we're going to talk about the nature of these forces. To understand it, first let me break this down upon two categories. One is called phenomenological forces. I know it sounds like a mouthful, but what I mean by this is very simple. Are day-to-day forces. Day-to-day forces. Okay, by that I mean the forces we keep talking about even in physics, like you're going to learn in the next modules, and also in the day-to-day life. Forces like normal, friction, which we call contact forces. Okay, spring force, tension force. Yeah, don't start to get scared and all. Okay, you learn, if you have not heard some of this, everything we are going to talk about in the upcoming modules. Sorry. Okay, so yeah, so normal force is nothing but if there is anything in contact. You've learned in maths, you have learned the word normal, right? Yeah, normal just means perpendicular. If two things are in contact, okay, there are two possible forces because of this contact. One is perpendicular to the surface, which is what I'm calling as normal force. Okay, and if I try to pull this, yeah, there's a resistance to it, that's the friction force. Yeah, I'm just introducing these names. We'll talk in detail about these in the upcoming modules. Okay, so yeah, these are phenomenological forces. Okay, by that I mean that these are forces which are not microscopically, or we're not talking in a very rigorous sense about it, but they are very useful because these are what you'll be encountering every day. Okay, but what I'm going to tell you is that there are there are a lot of phenomenological forces, muscular force, chemical force, this, that, everything you would have heard till now. Okay, and you'll keep learning. But life is not that hard. Okay, life is not that hard because there are some fundamental forces from which we can understand. If you go to the microscopic nature of this normal, this friction, any force, any phenomenological force, it will boil down to something at the fundamental level, which will be part of only a small list of 4. Okay, there are only 4 fundamental forces, yeah, that will cover all these phenomena. Okay, the first one is gravitational force. Okay, first one, not in some discovery sense or something, just for the sake of our list. Okay, so gravitational force. Second one is called the electromagnetic force, and I'll tell you what, all of these phenomenological forces are going to boil down to these two. These two are what we are going to see in our study of macroscopic motion. Okay, the third and fourth are the strong and weak nuclear forces. Okay, and right now we are not going to make use of them. These are responsible for some nuclear phenomena which we will learn later. Okay, right now what we are concerned about is the gravitational and the electromagnetic force. Okay, so yeah, in these, let me tell you a little bit about them. So gravitational force, you would have heard a little bit about that. It is the force which is responsible for things at the most, the scales of galaxies and solar systems, and the whole universe is pretty much run by this guy, because there is no shielding from gravity, and you learn about it much more in the next chapters. Okay, so right now there will be, in a lot of problems that you deal with, there will be, under the influence of the earth or the moon or some heavenly body, all the study of motion would be happening. So they will exert a gravitational force, a force due to gravity, and this is given by mg if we are near the surface. Okay, when we are near the surface, this is just mg, where m is the mass and g is the acceleration due to gravity. For Earth, this is 9.8 meter per second square. Okay, why mg? Because F equal to ma, and if I drop something, Earth is here, if something's dropped, it's not really far from Earth. Okay, this is just for educational purposes. Okay, if I drop it, then I know that gravitational force is the only force acting on it, because I'm neglecting things like the effect of air. Okay, then I know that Galileo actually threw stuff from the Leaning Tower of Pisa and measured it as far as the story goes. So I know that its acceleration will be g, and from mg, ma, force equal to ma, I can just replace a by g and I get the force of gravity. And yeah, if I put a table or something below it, Earth really doesn't care. Yeah, so this force of gravity will not change, it will still remain mg. By that I mean, in any equation, if there is the effect of the Earth, then this mg force will be acting always in a vertically downward manner. Okay, so now coming to the other forces that you will be dealing with. Okay, mostly normal force, spring tension and spring force, tension and friction are what you will be dealing with in this study of motion. Okay, so all of these forces are contact forces. Okay, by that I mean that if there's something, like I told you, kept on a table, there might be a normal force acting on it, which is shown by this N. Okay, if I pull it, there might be friction, there will be some spring attached to it, there will be a spring force due to the spring. I'll tell all of these in detail in the subsequent modules. Okay, and tension, by tension I mean not tension you're experiencing listening to all this. In physics, by tension what I mean is, if there is a string which is taut or tight, and it's connected by a string, it's connected to some blocks, then it's stretched, not stretched, it's taut, it's called taut, it's tight. Okay, and this causes some force. This force is what we call tension. Okay, so the big reveal for this, you should be, if you are a little curious, you would be thinking that, hey, wait, all these so many different kinds of forces you told, normal, spring, tension, how is this coming from this? You told from these two only everything will come, gravitational and electromagnetic. Yeah, so the story goes like this, that if I peek in to the molecular nature of microscopic nature of any of these forces, okay, which I will be doing as I'm introducing it one by one. Let's do it for normal, for the purposes of this right now. Okay, if I zoom in, if I look at this surface, then I'll see that all matter is made up of some atoms, and these atoms will all have some electrons in what they show to the world, the face that they present. There will be some electrons, because the nucleus with the protons and neutrons is embedded deep within the atom. So this is what they show to the world, and this has some electrons outside. By this I mean the block surface, and so does the Earth if it's kept on the ground or the ground. Okay, so there will be some, I'm sure this would be ringing some bells. There will be some electromagnetic or electrostatic in this case. These words, okay, don't get confused by the big words. This electromagnetism actually marries two phenomena of electricity and magnetism, right? And electrostatics means charges at rest. So if the electrons are at rest, or they are exposed to each other, they are very near each other, there is no real touch happening. Okay, if you go to, there is no contact, even ironically we call it a contact force, but there is no contact. Okay, because if I really zoom in, I can know that there will be some space between two atoms always, because of this electrostatic repulsion, or two electrons will always repel each other, and this repulsion is what at the macroscopic level is felt as the normal force. Okay, so and similarly, how tension and spring force and friction also depend on electromagnetic force. They all depend on electromagnetic force. Don't be surprised. Okay, so I'll tell you a way to remember this. Except weight, everything else is because of electromagnetic force in the phenomenological forces that you will encounter. Okay, so let's stop here with this. You try to digest this, and in the next model I'll tell you how to apply all this knowledge.